Hello guys, welcome to my channel, and in this video I'm going to show you how to build an application to detect faces using some very simple machine learning model. So let's get started. Okay, so the first thing we are going to do is to open up PyCharm. So this is a very popular code editor, and then we're just going to create a new project. Just hit this and then file new project. And right here we can specify the folder in which we will save this project into. I'll just save it in this folder and I'll create a new folder named face detector. Then okay. Then right here we can specify the environment that we are going to use. Right here I am selecting the previously configured interpreter, which is Anaconda environment. Then hit create. So we've got a new window open up. And in this folder, the first thing we're going to do is to create a new file named requirements.txt. Then okay. Okay, so the thing we are going to do here is to specify the library that we are going to use. In this case, we are going to use OpenCV Python with the version of more than 4.5. And then we're going to run it in our terminal. Just pip install our requirements. Okay, so you can see right here that the requirements is already satisfied. So we will go back to main.py and start the code right here. And the thing we are going to do is to first is to import libraries, which is CV2, and then we're going to specify the variable to save our captured video. So right here I'm going to use my camera to capture the video that I'm going to show next. Okay, so we have captured the video, and then while cap is open, while the camera is open, we will read into it frame by frame. cv2 cap.read, and then I'm going to show the captured frames in a new window. cv2.imshow. We'll just name the window as face detection, and we will show the frame. And after that, we're going to specify when we will break out of this loop. So if cv2.waitKey equals to the key q at my keyboard, we will break out of this loop, and then we are going to release the camera and also destroy all windows. Okay, so right here we have completed the access to the camera, and then we have read into the frames that is captured, and then we are going to show the frames that is captured, and we will break out of this loop when we hit the key Q. And then after we are done with the camera, we'll just release the camera and then destroy all windows. Okay, so let's try it by hitting the run button. Okay, so right here we've got a new window open. It is named face detection, and it will exit when we hit the key Q. Okay, so we have quit it, And after this, I'm going to okay, I'm going to just flip the camera. cv2.flip frames and 1. We can specify other other option here. 1 is for flipping horizontally, 0 is for flipping vertically, and -1 is for flipping both vertically and horizontally. So let's try it again. Okay, you can see here when I'm pointing right, the frames that is shown here is also pointing right. Let's quit it again, and then we will start to instantiate the model that we are going to use. So face detector equals to cv2.cascade classifier, and then we are going to use OpenCV model, which is cv2.data.harCascades plus the name of the model. So for the model that we are going to use, you can find it here. Just open up Google and then OpenCV source code GitHub. So you can see at the OpenCV GitHub, official GitHub, we can see the data here. And then we will just select harCascades, and there it is, harCascades frontal face default. We'll use this model, but you can also use the other models if you are going to plot, you're going to detect other kind of features as well. We'll just use this, copy it, and then paste it here. And then next is, okay, next I'm going to use this model to detect the face that is captured in my frame. So right here, faces equals to cv2, face detector dot detect multi-scale, and then we're going to insert our frame here. And okay, so we have detected the face using default arguments, and after that, for every faces that is detected, we are going to we are going to draw a rectangle by entering this cv2.rectangle, and then the frame itself, and this coordinate. After that, for the coordinate, we will specify it by extracting the features that is captured here. Width and height equals to base, and then we are going to specify the coordinates. This right here, the first coordinate is the minimum, and then the maximum coordinate of the bounding box, x and w, x and width, and then y plus height. Next is the color of the rectangle. Here I'm going to use green color, and the thickness of the bounding box, I'll just specify 5. And then okay, so right here we've got our rectangle drawn, and we'll try it again. Okay, so here you can see that there is my face that is detected in with using this model, and it is looking pretty great. But you can see that, yeah, there we have several moments in which there is a small rectangle that is detected that is not my face, and even this plugin is detected as a face. We're going to change a little bit of the arguments that is used in this detecting. Let's quit it and just specify the arguments here with minimum neighbors equals to, let's say, 10. And then I'm going to add a little bit of detail, which is I'm going to put text in on top of the box. So the text first is the frame itself, and then the text. I'll just write Tommy, for example, and then the coordinates of the text itself, and we'll input here x comma y. And then next is the font face. We will use CV2 font, which is cv2.font Hersey simplex, and then font scale we will put it 1, and then the color of the text I'll just use red color, and the thickness I'll just specify it as 2. Okay, so right here we have put the text on top of the box, and right here you have to remember that this CV2, this OpenCV, is using the arrangement of the color as blue, green, red, not red, green, and blue. So it's kind of reverse. And we will just try to run it again. Okay, so right here we have created a machine learning application to detect face using some very simple model, and that is my name, and we don't have any, I don't see any error in this detection. And that's it for this video. Thank you for watching, and if you like, don't forget to hit the thumbs up, and see you in the next video.